Welcome to the deep dive. We're looking at something fundamental today: software dependencies. All those free open source libraries we use.
Yeah, they seem like a no-brainer.
Exactly. Smart engineering, right? Don't repeat yourself. Just grab something off the shelf. Instant functionality, zero cost upfront. Or so it seems.
Uh-huh. It's definitely appealing. Why reinvent the wheel when someone's already built it? Often pretty well.
But that's where it gets interesting. We're looking at an article by Jamie Schembri, Your Dependencies Are Not Free, from April 2025, and it argues that, well, that convenience hides a lot.
Right. There are trade-offs, hidden costs, complexities we don't always see at first glance.
So our mission today, for you, the learner, is to peel back those layers, to get beyond the easy part and understand the full picture of using external code.
Mm.
We want to give you those aha moments.
Yeah, moving from just using dependencies to really understanding what that implies for your project, how that simplicity can sometimes lead to more complexity down the road.
Okay, so let's tackle this head on. This idea that they're not actually free. Open source sounds free, but what are these hidden costs Schembri talks about?
Well, the code itself might not cost money, sure,
Yeah.
but think about the time and effort, integrating it, keeping it updated, fixing bugs that pop up because of it.
Right.
It's like getting a free puppy. The puppy's free, but the food, the vet bills, the training, that all adds up. It takes resources.
That's a good analogy. And a big part of that cost, I guess, is the sheer variability in what you're getting. Not all libraries are created equal, are they?
And not even close. It's a huge spectrum. You have these fantastic packages, actively maintained, documented, security patches land quickly, really solid stuff.
The dream scenario.
Totally. But then you have the other end, libraries riddled with security holes that never get fixed, or they're just slow. They bog down your whole application.
Or they just don't play nice with other dependencies you're using.
Exactly. Incompatibilities. Or, and this is a fun one, undocumented breaking changes. Suddenly your app just stops working after an update, and you have no idea why.
Ouch. And then there's the whole issue of projects just getting
Mm.
abandoned. Schembri mentions this, like people start side projects, life happens, they lose interest or time.
Yeah, maintainer burnout is a very real thing. It's often just one or two people keeping a critical library alive, maybe unpaid,
Yeah.
if they step away.
You're left holding the bag, essentially. That long-term stability is a big question mark.
A huge one.
Okay, so quality varies, maintenance can disappear. What about complexity? You mentioned that earlier. How does pulling in one simple thing suddenly make everything complicated?
Right, it's like you invite one person over, and they bring their entire extended family, their cousins, everyone.
Ah, yeah.
A library, even for a simple task, is often built to be super generic. It needs to handle lots of different use cases. So it includes tons of configuration options, features you'll probably never touch.
Like the pagination example in the article. You just want simple page numbers, maybe next and previous links.
Uh, but the library might bring in code for like 10 different ways to style the pager, support for 5 databases you don't use, complex configuration systems.
And suddenly your neat little app has ballooned in size.
Exactly. And that's before you even think about transitive dependencies.
Ah, the dependencies of your dependencies.
Yes, that library you added, it probably relies on 10 other libraries, and those rely on others. It builds this huge interconnected web.
Which sounds fragile.
It can be. And that's where the whole idea of supply chain risk really hits home.
Yeah, supply chain attacks. It sounds dramatic, but these incidents show it's a real danger, right? This dependency web creates openings.
It absolutely does. Remember LeftPad?
Oh, yeah. Tiny little package removed by the author, and suddenly huge chunks of the internet, well, Node.js apps just broke.
It was a massive wake-up call. Showed just how interdependent everything is and how fragile that can make things, especially when you rely on tiny, maybe obscure packages for core functionality.
It really made people think twice about pulling in a package for something super basic. And then you have the outright malicious stuff, like that Peace Not War malware.
Right, where the code was deliberately sabotaged to cause harm. That showed the active threat aspect. People are trying to inject bad code into these widely used libraries.
And the backdoor incident more recently, that sounded incredibly sophisticated.
It really was a long-term, stealthy attempt to compromise a fundamental tool. The fact it got caught was amazing, really, but it highlighted how vulnerable these supply chains can be to determined attackers. It was a serious heads up for everyone.
Definitely makes you pause before hitting npm install or whatever. So, okay, avoiding dependencies altogether isn't practical, as Schembri says. What are the alternatives then, instead of just grabbing the first library you find?
Well, one idea that's kind of counterintuitive given how much we talk about DRY
Hmm.
is copy and paste.
Copy and paste, really? That feels wrong somehow.
I know it goes against the grain, but think about it in specific contexts. If it's a small, self-contained bit of functionality and you copy it directly into your project,
Okay. What's the upside?
you own it completely. Maintenance is entirely up to you. If you need to tweak it for your specific needs, it's right there. You don't need to submit a pull request to some external project and hope it gets merged.
Right, no waiting for maintainers.
And the code only does exactly what you need it to do. None of that extra bloat from generalization.
Schembri mentions examples like Tailwind's utility classes or Rails generators that scaffold code directly into your app, like for authentication.
Exactly. And even just copying a single function or method from a library, assuming the license allows it, which is crucial, can sometimes be simpler than pulling in the whole thing.
So a bit of strategic duplication might actually reduce complexity in some cases. Interesting.
It's a trade-off, like everything. Sometimes direct control beats theoretical elegance.
And the other alternative is maybe obvious. Just write it yourself.
Yeah, sometimes that's genuinely the best option. If it's a focused piece of functionality, building it bespoke can be quicker and cleaner.
It forces you to maybe get better acquainted with your language's standard library, too.
Definitely. There's often a lot of power already built in that people overlook. Or maybe you use a much lower level dependency that's a better fit instead of a huge framework.
And the benefit is clear. Less code overall, smaller attack surface, no unused features causing potential headaches.
Right, so it boils down to being more deliberate. Mindful dependency management, you could call it.
Okay, so what are the key questions we should ask ourselves before adding that dependency? Schembri lays out a few, right?
Yeah, practical stuff. First, does this function already exist somewhere, like in our own code, maybe tucked away, or in a dependency we already have, or, like we just said, the standard library?
He suggests asking senior team members, too. They might know something you missed.
That institutional knowledge is gold. Second, be honest. How long would it really take us to build this ourselves? Is it a day? A week?
Mhm.
A month?
And third, crucially, do we have the skills? Especially for security stuff.
Absolutely critical. If it's anything security-sensitive, authentication, encryption, handling user data. Schembri basically says, get expert help or use a very well-vetted library. Don't roll your own crypto unless you are a crypto expert.
Sound advice. What else?
Think about the future. How easy would it be to swap this dependency out later if we need to? Using something like a facade pattern can help here.
Right. Creating your own wrapper around the library so your code talks to your wrapper, not directly to the dependency.
Exactly. It adds a layer of insulation, makes future changes less painful if the library gets abandoned or a better one comes along.
Smart. And then the obvious checks about the library itself.
Yeah, the basics. Is it actually maintained? Look at commit history, issue tracker activity.
Yeah.
Are there incentives for continued maintenance, like paid support or upgrades?
And its track record. Any history of security vulnerabilities, how quickly were they fixed?
All vital signs of a healthy dependency versus one that might cause problems down the line. It's about weighing that initial convenience against all these potential future costs.
So yeah, the takeaway isn't dependencies bad, it's dependencies have costs. Real ones. Complexity, security risks, maintenance burden. We just need to be aware and make informed choices.
Precisely. Shift from just grabbing stuff to actually evaluating the trade-offs involved. Making a conscious decision.
Okay, so here's something for you, the learner, to chew on. Thinking about the projects you're working on now, are there any of those seemingly small, convenient dependencies that maybe deserve a second look after this conversation?
Hmm.
What might be the pros and cons if you actually tried to manage that functionality yourself directly within your project? Something to think about.
A really useful exercise, I think. Understanding the true cost, the true benefit of the code you build upon.
Absolutely. Well, that's our time for this deep dive. Thanks for joining us. Until next time, keep asking those questions and thinking carefully about the code you use.